So this video is going to be about stem plots. We're going to talk about how you draw a stem plot and how you compare or interpret stem plots. So because the definition is really long and I didn't want you to have to sit and watch me write it, I went ahead and wrote it. I'm going to read it to you and then I'm going to give you examples. If you want to pause the video and write the definition, you're more than welcome to. If you just want to watch the examples and refer back to the definition when you need it, you're more than welcome to as well. So a stem plot, some people also call it a stem and leaf plot, depending on the textbook that you're using or what the person has seen statistically. What it does is it shows each data value separated into two parts. The stem, which is all but the final digit, and then the leaf, which is the final digit. Stems are arranged from least to greatest vertically, and leaves are arranged from least to greatest horizontally. So let me show you a picture. All right, this is going to be caffeine content in micrograms of 8-ounce soft drinks. Once I show you what this looks like, I'm going to talk to you a little bit about what are some of the ways you think about this when you're going to draw your own stem plot or when you're interpreting a stem plot. So what you do is you draw this vertical line, and then on the left-hand side, you're going to go ahead and you're going to put the numbers. So for example, this is in micrograms. So if I had a soda that had 15 micrograms in it, I would say the first digit is 1 and the last digit is 5. All right, and I'll make a key for this, but I'm going to go ahead and write all the data out. And now, don't read this as 556 or 1,556. What this means is there were sodas, there were 3 of them. This soda had 15 micrograms, this soda had 15 micrograms, and then this soda had 16 micrograms. So the idea is this represents 3 different sodas where they were all in the tens, and then here are the second digits of their tens. All right, so this is their ones place. All right, then if we look at the next soda, we had some sodas that had in the 20s. We had one soda that had 20, one had 23, another one had 23, another one had 23, and then I had a couple that had 24 micrograms. Now, you don't have to do this, but if you have a lot of data, you might split your stem into 2 numbers. So for example, what you're going to see here is I had a lot of sodas in this study. They had a lot of sodas in this study that had ranges in the 20 micrograms. So what they did is they used this first 20 for things that were less than 5, and this next one is going to have anything greater than 5. So 25, 25, 26, 26, 27, 27, 27, 28, 28, 28, 29, 29. Okay, now you can see why they didn't put those all under just one stem, because that stem would have taken my whole board up. Now you don't have to do that. If you have a small enough set of data, you don't split the stems, but when you have a large set of data, you're allowed to split the stems, and we'll talk about that tip as well. Okay, then I had some things in the 30 micrograms. I had 31, 31, 33. Then I had 35, 35, 35, 36, 37, 37, 37, 38. And then because we had already split the 20s, it made sense to go ahead and split the 30s. Now, I think it really would have been more appropriate if they put a 1 here with nothing next to it, just because then you would have known there wasn't anything that was less than that. But because we started it, it's really not a huge deal. We also want to include a key, and the key literally describes what's going on here. So what I would say is 1-5 or 2-8 or whatever I want, whichever example I want to give, means, all right, that one soda has 28 micrograms per 8 ounces. So the whole point of the key is it's literally going to let you look at this and go, oh, got it. This 2-8 or this 1-5 or this 2-0 means a 2-digit number, and it represents the micrograms per an 8-ounce soda. All right, that's what a stem and plot looks like. Let me go ahead and erase the definition above this, and let's talk about the rules and sort of the recommendations for creating your stem plot. All right, now remember, this is video. I didn't pause and say, does everybody have this written? Because you didn't have to write that if you didn't want to. You should also throw some stuff around, especially if you had a long day. But also, if you want the definition, you can pause and rewind and pause and rewind and pause and rewind. You can freeze me so I'm making a horrifying face like this. All right, that'd be great. All right, so the first recommendation when you're drawing a stem and leaf plot is to go ahead and make the stems. There are two added tips here. The first one is do not skip an empty stem. And I'll show you that in my next example. That's sort of why I feel like they should have put a 1 above this, is because technically that would have been an empty stem because we didn't have anything below 15, but whatever. The next thing I think is really important, 5 is a good stem minimum. All right, the problem that you have when you start putting on too many stems or not enough stems is your data then gets very, very hard to read, all right? To me, I'm really glad they did this. They could have even gotten sassier and maybe split it into like decimals so that you had 3 columns for the 2 because there's so much data there. But notice, we didn't want to leave it as less than 5. You also don't want to get more than 5, right? So if you're working with something and you put 20 stems there, keep in mind you now have to keep track of 20 stems. So depending on your data, you generally want to do, I would say, between 5 and 10 stems. If you have a ton of data, then go ahead and do more stems. But you want to be able to look at your data and interpret what's happening and not spend your whole life trying to figure out how to put it all into your plot. Okay, the next thing is you would go ahead and you would add your leaves. And you want to, of course, watch your order for that. Notice, like I said in the definition, these went from least to greatest. These went from least to greatest. Okay? All right, the third step is you want to always add your key. And then these are the pro tips. Because you guys are pros now, right? You're not a bunch of newbies. If need be, round. They also call it truncating. For example, if I gave you, please don't write this, if I gave you this number, 5, 7, 8, 7, that was not even a number, 5, 2, 1, 8. Please don't put that in your stem plot, all right? Depending on what you're talking about and for how precise you need to be, like you need to be this precise if you work at NASA or you work at SpaceX and you want to make sure that people are landing and being safe, and this is engineering purposes. If you're trying to let me know how much your, I don't know, something weighed, all right, maybe you took your stack of books at home and said, oh, they weigh 14.23578, be like, okay, you don't need all that. So maybe you would round it back maybe to here and say, oh, that's about 14.24. Maybe you'd even get sassy and round it back to 14.2. I wouldn't recommend going all the way back to 14 unless everything else is also in whole numbers. When you write that in a stem plot, you are allowed to, and I'll show you this in my next example, use the decimal as your secondary, okay? You don't have to round, but you certainly don't want to be spending the rest of your life working with really gigantic numbers, all right? The other thing is, if you split the stems, try to keep them equal. I'm sorry, there's someone beating on the floor upstairs, one of my children, I'm sure. All right, so like here, you notice these two aren't going to be equal, but splitting at 5 is a really good spot. What I would have actually recommended to the person that made this, because I didn't make this, I just copied it from the textbook because I wanted you to see what they did, and I wanted to show you how I thought they were wrong. I would take the 5 and the 5 here, and I would have gone this one 0 through 5, and then this one 6 through 9. Now, that's not a complete equal splitting, but when you actually go to write it out, it makes it so that the two data points just look a little better. Normally you would go 0 to 4 and then 5 to 9 because that's equivalent, but you're allowed to split however you want as long as you give me a key. All right, so the last thing that we're going to do is we're going to look at an example where we have 2 sets of data that we want to compare, and how sometimes people will do a stem plot that involves data on both sides of the stem. Okay, so I'm going to go ahead and erase my pro tips, and then I'm going to put my data up. Remember, with these videos, you don't have to take notes on anything you don't want to. You don't even have to take notes if you don't want to. But the reason that I'm going through them is because the idea is to help you with the assignment that you have for this. So if I'm covering something, it's because it's something I want you to see, because it's something you're going to get asked about. This is mass in grams of fun-sized Snickers in 2 bags. So what happened was, someone, and it wasn't me. I wish I had fun-size Snickers in my house right now. Somebody went and got a couple of bags of fun-size Snickers, and they took and they weighed them in grams, and then they recorded their data. And then what they did is they put their data in a stem plot. And notice I put 2 lines. That's because the stems are going to go in the middle. And what I'm going to do is I'm going to have leaves off to the right and leaves off to the left. So this one is going to be bag 1. This one is going to be bag 2. Because they're similar things, their stems are all going to be the same. I have a 15, a 16, a 17, an 18, and a 19. And now I'm just going to write these down. Now I know that that looks backwards, but remember, if I'm reading it this direction, this should be least to greatest. Okay, now the first thing I want you to think about is, are these bags equal? Did they have equal numbers? Now, I don't know if you've ever bought Halloween candy and been like a weirdo that counts your candy out, but when a company sells you things in bag, they don't have to guarantee you generally the number of objects in the bag. They guarantee you the weight of the object, of the bag itself, and they also are allowed to be slightly different within usually a couple of ounces depending on what they're doing, or micrograms, depending on what their measurement is. So you might buy one bag of Snickers and it has 20 Snickers in it. You might buy another bag and it has 21 Snickers in it. It's the same with, like, if you open a bag of Skittles. If you and a friend open a bag of Skittles, you won't necessarily have the exact same amount of Skittles because they do it by weight of the bag, and they're allowed a little bit of error on either side. This one, though, I think we've got equivalent numbers. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 14. So, yes, one bag had one more Snicker than the other. So that is something you can tell from a stem plot. I also forgot a very important thing here. I need my key. I'm going to say 15-9 is a Snickers with a mass of 15.9 grams. All right? Now, I could ask you all sorts of questions about this. I could say, who has more bars? On average, which bag has bigger bars? I could say, I look at 18 and I notice this one doesn't have any numbers. What does that mean? All right, so let's talk about it. Which bag has more bars? Well, we just counted it. If Miss City can count correctly, which you never know, it looked like this bag had more Snickers in it, all right? So that might be, you might be one of those people that like, I'm going to write an angry letter to Snickers now. Whatevs, do it. All right, the next one says, on average, which bag has bigger bars? So now let's look. This bag has a 19.4 ounce bar. This one has two 19.2s. This one has an 18.1 ounce bar. This one has 17, 17, 17, 17.1, 17.1, 17.1, 17, 17.1, 17.1, 17.3. Now, this one has two 19 bars. This one has 118 and 119. On average, who do you think has the bigger bars? And this is where statistics is interesting, because it really is open to your interpretation. I might have somebody that says, well, I think bag 2 has more because bag 2 has more 17 gram bars. They're the only bag with an 18 gram bar, and their 19 gram bar is the biggest. Another student might say, well, yeah, but this bag has two 19 gram bars, so I think theirs is biggest. And this is why statistics is used for good and for evil, because the interpretation is open to how you then defend your answer. Okay? So on average, which bag has bigger bars? You could decide either way and be correct as long as you defended your math correctly. You might be the person that you actually go through and you find the average on both sides and then decide. Okay? But the idea is that as long as you can defend what you say about the data and with your data, then you can answer however the heck you want to. All right? Which bag would you rather buy? Right? Some people might say, oh, I would rather buy bag 1 because it's got more. Some people might say, I'd rather buy bag 1 because it's got a lot more heavier Snickers. I don't know, maybe you don't like heavy Snickers. Maybe you're like, oh man, I totally want the one with less Snickers. I have no idea. I don't know your life. All right, but so Stemplot, stem, leaves, and it lets you answer questions. One that has one stem with one set of leaves is about one set of data. Anytime you do this double here, this back to back, they have to be the same thing. I couldn't take and do Snickers on one side and then do soda on the other side because those are not related things. All right, so you now have an assignment on this. It is in your Sapling Learning. It is 1.4, and it's, I think, like 5 or 6 questions. If you have questions for me, please make sure you ask. You can email me. You can send me a remind. You can stop into my office hours, which I have every day. You can wait and ask in class on Wednesday. It's totally up to you. If you need me, please get a hold of me. I hope you have a great day, and I will talk to you later.